Stoichiometry is not going to work without a balanced equation. Sulfur. 1 iron, 2 sulfurs, and 2 oxygens on the reactant side. Law of conservation of mass says those same elements have to appear on the product side. Now oxygen appears in 2 different compounds, so I'll put each of those, represent each of those in its own line while I'm showing my work. We're going to start, multiply that by 2. All right, so we got 4, and then we got 6. Whoops. No more mistakes for the rest of the year. That's it. 6. All right, so now let's go back to the left side and balance the irons out. 4 is 4. Update that one as well. 8, go to the right side, find sulfur, multiply that by 8. It's going to give us 8. Let's update that one now. 8 times 3 is 24. All right, so now we got an even number. There we go. We can always reduce if we overshoot this thing. All right, so this is going to be 15. Give us 30 on both sides. Put 15 there. Let's do the stoich. All right. So it says how many grams of sulfur trioxide. So we're looking for this stuff can be made when we have 20 grams of iron sulfide. All right, so your basic stoich. Oh, and then we're also we gotta do this twice. All right, we're gonna see which one of these is the limiting reactant, and then use that to calculate any kind of percent questions we have. All right, let's do one at a time now. I'm gonna do this here, and I'll do the iron one in red. This one here. 20 grams of iron sulfide. Iron disulfide. That's what that's called, I believe. 20.0 grams of FeS2. First step, stoichiometry, convert that to moles. We need molar mass to go between grams and moles. Mass and moles, moles and mass, we need the molar mass. It's not even on my periodic table. All right, so I'm gonna look this up. Gotta find the periodic table. Here it is. Fe is 55.93. All right, and there's 2 sulfurs. Sulfur's there, so 32.07. Just going 4 digits because I'm gonna have to round to 3 times 2. 64.14. Let's add them up. 7. What? Too many numbers on my screen. Hold on. Let me just use my calculator. 55.93 plus 64.14. 120. 120.07 is the molar mass. 120. Just going to round that to 120.1 is the molar mass of iron disulfide. Sorry, can't round it there. Grams per 1 mole. If we had Avogadro's amount of this compound, it would have a mass of 120 grams. Let's cancel that out. Step 2 is going to use the mole ratios to convert to the substance we're looking for. So we want to get rid of iron. We don't want to know about iron disulfide. We want to know about how many grams of sulfur trioxide. Sulfur trioxide. So this is where that conversion happens. All right, so let's check out the balanced equation, find the ratio between sulfur trioxide, which is right there, and iron disulfide is right there. So it's a 4:8 ratio. 4:8 ratio. Those units are canceling out. Now the final step is to, well, we're done if it asks for moles, but let's see, does it ask for units of sulfur trioxide? How many grams? How many grams? How many grams? So we're going to find the molar mass of sulfur trioxide. Moles to mass, moles to mass. All right, well, I had sulfur there, so sulfur 32.07 times 3, because it's oh, no, it's not. 1 sulfur. Trioxide means there's 3 oxygens. So oxygen is 16. There's 3 of those. It's 48. All right, let's add them up. Well, that's going to be, oh, I got this one. 80.07 grams per mole for SO3. Sulfur trioxide, 80.07. All right. 80.07 grams of SO3 per 1 mole of SO3. That's called molar mass. All right, cancel those units out and let our calculator do the rest. 20 divided by 120.1 times 8 divided by 4 times 80.07. All right, 26.7 grams of sulfur trioxide remains, or that's how much we can produce if we started with 20 grams of iron disulfide. Now we got to figure out how much we can get if we have if we started with. So I'll use blue here for this one. 16 grams of oxygen. All right, so 16 grams of O2. We'll do the same thing. Just start with a different reactant. All right, what's the first step? Students, what's the first step? If you're not given moles, it's to convert to moles. All right, so there's in O2 there's 32.00 grams of oxygen. That's just from your periodic table, and every 1 mole of O2. All right, so units cancel out. Now let's use the mole ratio to convert moles of the given substance to the moles of the desired substance, which is SO3. All right, so I know that's 8. I'm looking up there. Now oxygen, we're going to have to go back to our equation. Oxygen is a 8 to 15 ratio, or 15 to 8, however, depend how you want to look at that. All right, but 15 moles of oxygen are required to produce 8 moles of sulfur trioxide. And then this part here, we're just going to copy right there. Just copy that. It's the same conversion factor, moles to grams of sulfur trioxide. Wouldn't be bad if I just messed up here. Okay, let's see. 16 divided by 32, that's just a half, times 8 divided by 15 times 80.07. So 21.4 grams of sulfur trioxide. If we had 16 grams of oxygen to start with. All right, so go ahead. Which one of these is the limiting reagent? Which one of these reactants will produce the lesser amount of product? All right, so that's the oxygen. So that's called the limiting reagent. Right, and then the stuff you have left over is called the excess reagent. Right, now this is going to determine how much you can actually make. So that is known as, right, this is known as your theoretical yield. All right, so hypothetically, you could make a maximum of 21.4 grams of sulfur trioxide if you had these quantities of reactants. So we're almost done. Let's do this percent yield question. What is the actual mass, all right, if the percent yield is 95%? All right, so we're given the percent. It's 95%. So here's what you need to know. Actual over theoretical times 100 gives you percent yield. So we're just going to plug in the numbers. All right, so we've calculated the theoretical to be 21.4 grams. It's given us the percent was 95%. Was it 95.5? No, 95.0%. And it's asking us to find the actual. All right. So there's many ways to do algebra, but I'm going to get rid of this percent here and just move that decimal back to where it was to move it 2 spots to the left. Now that percent is a decimal, and I'm just going to multiply, cross multiply there is 21.4 times 0.950. Let's see what that gives us. 20.33. All right, 3 sig figs, significant figures. Oops, this is not a percent. Sorry. Oh man, keep track. All right, this is grams of sulfur trioxide. That's how much was actually made if the percent yield is 95%.